Is fall about to start with surf, rain, and snow? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 12th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people. All the time, no hype.
If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below. The heart with the $sign in it. With that, I'd like to thank the folks that donated last week. E. Slate, Tim Caston, Elliot Harris, O. Dillard, Clay Goose, B. Nadine, Craig 8638, Mark Denzer, and then two larger contributions, one from Leona Roberts, and then a really large one from Slade Fester. Thank you all very much. I mean, it's a long list of people. I really appreciate it. Kind of overwhelms me every time it happens. Anyway, thank you all so much. And with that, let's get to work. We'll start by looking at significant wave heights around the planet. We'll start up in the North Pacific. Yeah, a little bit of a gale here with 23-foot seas off the Kuril Islands. That's Kamchatka there, the Kuril Islands, Japan down here. Tropical system south of Japan, but no indications of recurvature expected there. So all in all, a kind of quiet pattern, at least for the moment in the North Pacific. In the South Pacific, a gale with 24-foot seas southeast of New Zealand, some other scattered areas of fetch with producing 22, 23-foot seas, but definitely South Pacific starting to wind down. North Atlantic, a little bit of a gale with 20-foot seas approaching Europe, and some sort of a, what do you call it, a northeaster low-pressure system off of, for the most part, off the mid-Atlantic coast, generating fetch, pushing into the coast there. Been a prolonged bit of surf for the U.S. East Coast, which is much needed after a long summer of practically nothing. South Atlantic, really quiet for the moment, but you can see here in the Indian Ocean, a gale with, it says 30.1-foot seas. These are the highest seas over this entire domain. I sound a little bit incredulous because I don't see any purple there, but there's probably one tiny grid square, you know, like a 15 by 15 nautical mile square embedded in there with 30-foot seas. But for the most part, it looks like 28 to 29-foot seas. And these are the coordinates of where those high seas are at. And yep, it works out as expected, and max winds 31 knots there. So it must be a fading gale that is producing that. But let's first talk about current conditions. We're going to start by looking at the buoys. I'll start up, as usual, up in the Pacific Northwest, Grays Harbor. Buoy number 036, that's off the border there between Oregon and Washington. We're looking at all the energy that's currently hitting the buoy all the way up from 33.3 second period, which there is 0.0 feet, and the whole way down to 5 second period, which would be like really short period stacked together wind waves, just basically unrideable chop. We see most energy in the 9 second period band, so that's pure wind swell. Let's see how the algorithm does at tearing this all apart and figuring out where all the real swell is. Primary swell, 8.1 feet, 9 seconds from 301 degrees, making surf at about 7 foot. And looks like it did a pretty good job. Secondary swell, 1.8 feet at 12.5 seconds from 288 degrees, making surf at 2.3 feet, but that's all buried under the wind chop. Then we head down to Northern California, the Point Reyes buoy, 029. So that's just north of Ocean Beach, San Francisco. Same sort of profile. A bunch of wind swell here in the 7 to 8 second period range. And little bits of background swell energy in the mix at 12 seconds, 15 seconds, and something out at 20 seconds. Let's see what the algorithm says. Primary swell, 8.5 feet at 8.5 seconds from 310 degrees. Again, making surf at about 7.3 feet. Then that background energy, 1.9 feet at 13.2 seconds from 284 degrees, making surf 2.5 feet. And that, I'm sure, is all buried under the wind swell. Down to Southern California, the Point Loma South Buoy, 191, they're off of San Diego. A much more subdued pattern for this area, just steady readings across all the spectra from a half a foot up to maybe 1 foot, something like that. No clearly defined swell. Primary swell 2.4 feet at 9.9 seconds from 247 degrees, making surf at about 2.3 feet, and then some other energy thrown in there. 1.4 feet, 13.4 seconds from 191 degrees. So this is some southern hemi background energy at about 2 feet. And then over to the Waimea Bay buoy, north shore of Oahu, buoy number 106. Look at this. We have a bit of energy showing here, 1.3 feet at 22.2 seconds. I think that's a bit larger and a bit longer period than was expected. That coming from a gale previously off the Kurill Islands. We'll get into that in a minute. Then some other swell in the 12.5 second period range and some wind swell in the mix. Let's see how this does. Primary swell from a surf height perspective, 3.5 feet at 11.9 seconds from 321 degrees gets you surf at 4.1 feet. And then we have this secondary swell building 1.6 feet at 21.5 seconds from 319 degrees, giving us surf at 3.4 feet. And the assumption is that it's coming up. All right, so let's review what's been going on for the past week. This is a Hindcast model, significant wave heights for the North Pacific Ocean, tropical activity off of California. This was last week, Sunday, the 5th of October, and really not a whole lot else going on. We'll put this into motion, see where we're at. It's Monday, Tuesday. There was Hurricane Priscilla at one point. Didn't make it as far off to the west or as far north as expected with any strength, but it still did produce wind swell that radiated up into exposed breaks in Southern California. Another tropical system, I think this was Neo-Guri off of Japan. We're into Thursday here. We had some problems with the models, so you'll see me kind of clicking a bunch here. Neo-Guri took off to the east, recurved with seas. I think we got 46.8 foot reading at 33 north, 146 west, while this other system off the Kurills and Kamchatka started building with, that's about 36 foot seas. I think that's about as far. Oh, there we go. Let's see. 30, 31, 32, 34, 36, 37, 38 foot seas there on Thursday night. This is the swell that is starting to hit Hawaii. So, and that's about right. 38 foot seas will get you, honestly, about an 18-second period. But if you get some good forerunners, maybe in the 20-plus second period, probably not a whole lot of size is going to be expected from this. Most of the energy aimed off to the east. The Hawaiian Islands, at least 45 degrees off axis there. So, but you get the idea. And swell from this is also going to be radiating towards the U.S. West Coast. That all sort of faded out, and that's where we are as of the 12Z run of Sunday today. Now, over the past week in the South Pacific, there was a little gale here in the central South Pacific. In fact, I think I can actually go back a couple more frames. You see it started on Saturday, lifting north 28, 29 foot seas, but over a very tiny area. All this energy going to bypass the Hawaiian Islands. Oahu's like at 158 west. This was all east of there. This is going to make small swell for mainly Southern California and down, of course, into Mexico and those areas. But probably not a whole lot of size expected. By Monday, that all faded out. We'll just put this into motion here. Wednesday, Thursday, and there we go. Friday, where is it? There it comes. We had some issues with the models, and we did a operating system upgrade on all our servers, and of course that never goes as smooth as one would hope, so things got kind of stuck, and I had to dig through all that. Then over the past week in the North Atlantic, we'll put this into motion. That was a tropical system. That was gone. Here comes, this was Jerry right here on Wednesday, the 8th of October into, let's see if we can get to Thursday here. Right, lifting north. Didn't make a whole lot of westward progress. I think mainly there was fetch off here associated with other low pressure in this area. And that's what is created as we get into Sunday. You'll see it here. Low pressure off the coast, creating what they typically call a northeaster. It's a lot of northeast winds, creates raw wind swell. I mean, Central Florida has had head-high surf for at least a week, if not more, which is much needed considering how bad things were earlier this summer in that area. So a nice bit of steady wind swell to keep people happy. Then off to the South Atlantic. We'll put this into motion. See what sort of activity happened. I mean, it's really, things are starting to quiet down in all the southern oceans, as would be expected given the time of year. We're into Saturday. I mean, I'm not seeing anything, and here we are. So a very quiet pattern for the South Atlantic. And then to the Indian Ocean. We do know that there is a gale there. Here's one little system, 28 to 30-foot seas. That was on Tuesday, the 7th of October, pushing up into southern Australia. Another little system there falling south, southeast. Now, here we go, into Friday. 44-foot seas. Did it get any higher than that? Nope, 43 feet. That system has produced swell. You see the swell front here as of Sunday. We'll just put this to current time. Approaching Western Australia and certainly up into the Mentawai Islands and Bali. So at least one more swell for the Indian Ocean before things start really quieting down. So what is coming for the future? And we're going to dive in here really to focus on the North Pacific. We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, the jet helps direct their track. We're looking for a trough, a push in the jet to the south, and you can see it plain as day right there. Southward push, you get an eddy flow aloft, a counterclockwise eddy flow. That's the hallmark of low pressure in the upper atmosphere, but that typically manifests itself down at the ocean surface too. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, starting to generate seas. Those seas, as they radiate away from the fetch area, the lesser period elements decay off, exposing longer period swell. Swell, when it hits your beach, turns into surf. But it all starts with the trough. The good news is we have a consolidated jet stream flow in the west, as has been expected for like months now. The focus, we really believe, is going to be the West Pacific this coming winter, just given the where the low pressure bias is and things like that. We'll get into that discussion in a bit. But anyway, you have a trough here going to about the date line. The Aleutian Islands right here. The jet lifts north of there. And then you have typically, and when you get these ridges like this, you'd get high pressure out here. But also notice a backdoor front pushing off the Pacific Northwest. This is pretty typical of La Nina. During La Nina, most low pressure is focused in the West Pacific. You have high pressure somewhere here in the Gulf of Alaska. But if you get lucky, the high is actually far enough to the west that allows the jet to dip south down the U.S. coast, it brings rainfall, but it's not like the heavy tropical moisture-laden atmospheric river types events. What it is it drags cold air with it, and cold air and whatever moisture you have wrings out lots of snow, and this looks like it's one of those sort of systems. Let's put this into motion. So here we are, Sunday. Monday, full-on backdoor cold front coming in Northern California. The jet on the 45 north latitude line just pushing right across. Pretty much what you'd like to see. The backdoor cold front hangs out into Tuesday, finally moves onshore sometime Wednesday, but the jet remains consolidated and reasonably strong for the time of year across. And here's the even better part, across the Pacific, but now consolidated, and the ridge starts fading as the jet basically builds the whole way across the Pacific, a little bit north, maybe 47 to 48 north. But for early season on a La Nina year, we'll take it. And then as we get into Friday, the 17th of October, a trough starts building here in the northwestern Gulf of Alaska. Another one south of Kamchatka. And here we are into Saturday with a full-on legitimate trough in the Gulf of Alaska and another one pushing off of Kamchatka. Let's see, we got two more frames there. And all in all, this looks like a very good pattern supportive of gale development in the North Pacific Ocean. We'll take it. Then we go down, take a look at surface level pressure, surface level winds. As expected, high pressure here in the Gulf of Alaska. That's the jet driving to the north here. That's what you would expect to see. Northwest winds down the coast at a good clip, and a little bit of a gale. 35 knot winds constitutes gale, so minimal gale off of the North Kuril Islands. Put this into motion as we get into Monday. Here is some very limited fetch associated with the backdoor front. So the backdoor fronts really are not surf producers. They are more weather producers, and 30 knot winds, that's not even what I would call swell. It's just enough to make wind swell. Tropical low pressure here pushing off of Japan. Again, another low setting up in the northwestern Gulf, building with 45 knot winds aimed at the U.S. West Coast, not so much at Hawaii. And you just sort of see how this all goes. That low pushes off to the northeast. It's actually looking better than it has over the past couple of days. Again, still a couple of days from forming, but there is definite hope there. Then we get into Thursday, and you see things starting to wake up. There's a trough here. Gale starts to develop. Subtropical low pressure pushing off of North Japan, lifting northeast. Boom. Storm, 55 knot winds forecast approaching the dateline. Another storm with 40, or gale, 45, well, almost a storm, 45 to barely 50 knot winds in the Gulf of Alaska. This is on Friday. There you go, 50 knot winds into Friday night. And Saturday, well, that's a beautiful looking setup. 45 knot winds aimed right at the coast, 55 to almost 60 knot winds on the dateline. Now lifting north here as we get into Saturday. Got one more frame here. Still 55 knot winds. I mean, this is like great. And you see some sort of a tropical low over here. I don't think that's going to recurve, but it sort of looks like it wants to. All right, so what is the effect of those winds on the ocean surface? Well, we know off into the future there's some serious winds forecast, so one would expect the ocean to respond in kind. But for right now, we looked at this before, 23-foot seas off of North Kuril Islands, not a whole lot going on. Our first little gale, there's a tropical low pressure recurving again, but it's really, it's its own thing. A new gale starts developing, we'll call this Tuesday, 30-foot seas to 31-foot seas Tuesday night, up to 33 feet later Tuesday night, and that's about the peak of it. And that's about what the models have been saying. They've been debating on how far north up into the Bering Sea and how far south they're going to go. But the 12Z run today says bit further south than what was previously forecast. All this is good for producing swell the whole way down the U.S. West Coast, down to Point Conception from a rather northerly angle. I mean, up here is like just off the top of my head relative to Northern California. I think it's like 306 degrees, something like that. So this looks like it'll be a 306 to 310, 312 degree sort of angle swell. So not bad. Nothing too outrageous, but maybe something to get warmed up on if local winds aren't too bad. And then we get into Friday night, Saturday, the 18th of October. First little gale starts building in the Gulf of Alaska, 28-foot seas, bit more energy further back. Oh, and the 51-foot sea here, that's related to a tropical system. And then we're into Saturday, there's 32-foot seas targeting the U.S. West Coast and in pretty close proximity with seas here building to 44 feet. Is that right? Yeah, 44 feet approaching the date line, building to 42, like 45 feet. And then peaking out at 46 feet on the date, right on the date line, aimed off to the east, while seas ahead of it, still 29 feet, targeting the U.S. West Coast. This is on a Saturday night, and then we'll put this into motion. So we get into a week from now, still plenty of activity, potential for swell development. This is looking good. Let's go back here and just see what this guy is doing. Oh, you do see the tropical system. Again, this is a week out. I don't know if I'd believe any of it. You almost get the sense it's trying to recurve. That would be really interesting if it did. But again, Don't believe a model more than 5 days out. Anything more than that, you're into pure fantasy land. 2 weeks, forget it. It's just a joke. So 5 days, 7 days if you really want to push it. But given how these systems here have been on the charts now for multiple days, and the forecast is really not wavering, maybe we won't get seas as high as what is forecast, but it certainly looks like there will be surf. Down to the South Pacific, my expectations are very low. We're going to blast right through this because I don't think there's anything to be had here. The season, for the most part, is over, other than some small little swell that's bound in for Southern California. You saw it on the Hindcast charts. That'll show up probably Monday, Tuesday sort of thing. To the North Atlantic, let's see where we're at. The pattern has been tropical low pressure tracking up this way following the Jetstream smashing into Europe. Well, another system. Now this one, not so great. 27-foot seas, not really aimed at Europe proper, but still capable of making some surf somewhere. But let's see. Anything larger on the charts? We're out multiple days. Now notice this low pressure system here just continuing to circulate and orbit off the northeast coast. That should make some degree of swell pretty much for the whole work week, and we're into Sunday here. Finally, it starts moving out. To the South Atlantic. Again, expectations pretty low here. One low literally falling into Antarctica. But then look at this. As we're into Thursday, the 16th of October, a gale is supposed to develop with 36-foot seas and 37 feet tracking south. This would definitely be swell for South Africa, both the west side and the at least the downward facing portion, and then fading as we get into Saturday. Possible late season swell. Again, it's kind of pushing the edge of the model there, but maybe some hope if it all plays out as forecast. And then to the Indian Ocean, we have fetch. We see it here, 29-foot seas, but that's fading out all from a previous gale. See the, we can actually go back and you can see the swell front from it right there, approaching Indonesia and moving in on Tuesday, the 14th of October. After that, what do we have? Any luck? Couple of very small systems, but no, things getting pretty quiet. It seems the northern seas are taking over with the change of season as the southern hemi starts to go to sleep. Local wind forecast for California here and Hawaii. This would be Southern California. There's Point Conception, Monterey Bay, San Francisco Bay, and then Northern California, Cape Mendocino up there. And of course the Hawaiian Islands over here. As we talked about before, high pressure, 1034. Actually, it looks like it's maybe, 1034 millibar high, moderately high pressure, setting up in the Gulf of Alaska, ridging into the coast, producing northwest winds at 20 knots, mainly south of Monterey Bay. Trade's pretty light. This was on Saturday. We'll get into Sunday. Pretty much the same pattern. Building northwest winds, though, today on Sunday for California. Trade's light for the Hawaiian Islands. We get into Monday. Here comes the backdoor trough. Low pressure inland, high pressure out at sea, tightens up the isobars. You see these little lines getting closer together. That creates more wind. You see 20, 25 knot northwest winds. That will definitely make wind swell, but and notice winds are supposed to be pretty light along the coast. So maybe rideable wind swell. Trades on Monday for the Hawaiian Islands at 10, maybe 15 knots. And Monday night, you see that 30 knot northwest winds. And then by Tuesday, the low looks like it's starting to settle down. A light wind regime along the coast. Trades 10 knots or so for the Hawaiian Islands. Get into Wednesday. All that just fades out completely. Here's our gale forecast for the northwestern Gulf of Alaska with a light wind regime for Hawaii and California. Get into Thursday. Here comes more high pressure, though. Northwest winds start building. We'll say 10 to 15 knots along the California coast. Trades build. There's the center of your high. It's like a double lobed high. 15 knots for the Hawaiian Islands. Get into Friday. Here's your typical pressure gradient. Now, the good thing here is it's all focused on Cape Mendocino with northwest winds at 20 to 25 knots, but a rather lighter wind regime south of maybe Bodega Bay, something like that. Trades 10 to 15 knots for the Hawaiian Islands. Then we get into Saturday. Look at this big low pressure sitting here in the Gulf of Alaska. A relatively weak wind regime south of Point Arena, I'd say. Trades 15 knots for the Hawaiian Islands. And then here we are 180 hours out the gale off the coast of Oregon, 35-knot winds, a light wind regime, and trades 15 knots for the Hawaiian Islands. Not a bad setup. And then let's take a look at the potential for precipitation. High pressure in control, but we know there is some sort of a backdoor trough already organizing. There you go. As we get into Sunday night, rain for Oregon, snow in the higher elevations of the Cascades. That low starts falling south, reaches Cape Mendocino on Monday, mid-morning sort of thing. You already see forerunner snow showers setting up in the Tahoe area, if not down to Mammoth. Rain fully engulfing the Bay Area by Monday night and sinking south. Let's see how far it gets. There's Point Conception on later Monday night. Heavy snow set up for the Sierra into Tuesday morning. And then as we get into Tuesday afternoon, rain starts breaking up, let's say north of San Francisco, but snow continues for the Sierra into Tuesday night. Wednesday, that all clears out. We're into a lighter wind regime. We're into Friday, Saturday. See another low. Here's that low setting up in the Gulf. Will it make it into California? I don't know. It's too far out to make a guess. I mean, let's just work on the surf component of this thing first before we get over our handlebars here and start worrying about yet another snow setup. Hikers temperature profile. I think this is now becoming more of a Sierra temperature profile. You get the idea, and this is a little bit old. So Sunday is here. Temperatures in the, let's say, 40 to 35 degree range on Sunday. But as you get into Monday, you see temperature. The red line's the freezing line. Boom, falling freezing temperatures by Wednesday the whole way down to 4,000 feet sort of thing. Then, as would be expected, temperatures just rocket right back up as we get later into the week, Thursday, Friday, at the 8,700 foot mark in the 40 degree range sort of thing. But then theoretically dropping back down again as we get about a week out. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. This data is a little bit old, but you get the general idea. Snow amounts in the 22-inch range sort of thing. Accumulation, I think that's probably overstated a little bit. Yesterday it was saying 19 inches, but I think it would be safe to say up to 2 feet of snow at top peaks, top elevations, and then maybe even a little bit more. This goes out 10 days. You see a little bit more, a couple of inches of accumulation beyond that. So typically I say, okay, the rainfall season starts. We get our first rain here in the San Francisco Bay Area, somewhere between mid-October and Halloween sort of thing. Looks like we're right on cue for that on the 13th, 14th, but snow, typically we don't get snow, or certainly not anywhere in the 2 feet sort of snow amount of accumulation. So if this thing actually verifies, if this storm does what it says it's going to do, this would be a very, very good start for a winter season up in the Sierra. Good for dampening fire potential, at least in Northern California. And I think the rainfall, if I looked, it was going to work its way the whole way down into Southern California. So, in fact, let's go take a quick look. So I'm just going right to Monday tomorrow. Here's the rain pulling into North and Central California. And there you go, Southern California Tuesday. Looks like rain the whole right about to San Diego. Maybe not any further than that, and then all clearing out as we get into Wednesday morning. So 24 hours of rain potential for Southern California. And if we're going to look at Palisades, Tahoe, we got to go look at Mammoth as well. Snowfall accumulations and some amounts, about 11 inches it looks like. So all in all, a good start theoretically if this all plays out for the Sierra. All right, surf forecast. We'll start up in the Pacific Northwest, the Columbia River area, right there on the border between Oregon and Washington. Surf heights today, it says 5 feet. The buoy says it's probably 7 feet sort of thing. Either way, flattening out into pretty much nothing as you go through the work week. But then we get into the next weekend, 12-foot surf, building to 18 feet. Of course, all courtesy of gale, low pressure in the Gulf of Alaska, and then a much stronger system out on the dateline. Winds out of the some version of the south there as we get into Saturday. Swell heights, 5 feet at 9 seconds, dropping off to near nothing. Then start building 6-7 feet at 15 to 16 seconds, 12 feet at 15 seconds. And I think it's going to go a bit longer period than that if we actually get those 44, 45 foot seas the models are projecting. Ocean Beach, California, not a whole lot at the moment. 6-foot surf supposedly as we get into Tuesday. I'm sure that's all local wind swell or swell generated by the backdoor trough or low as it pushes over the air, dropping off. But then sea heights start building, or swell heights, surf heights, 6 to 7 feet on Saturday and likely coming up from there. Let's go look at some swell heights. Yeah, here you go. 6 feet at 10, 11 seconds, local wind swell. And then things start getting interesting. 4.5 feet at 15 to 16 seconds. That's a good way to get your arms warmed up at Ocean Beach. Well, that'll be a good little paddle. Down to Southern California, surf height, so you can see it pretty much for yourself. 1.5 to 2 feet the whole way through the week. Most, at least the first part of this, and actually both these storms, because they're positioned so far to the north, it'll have a tough time wrapping around Point Conception to get into Southern California. But top exposed breaks could probably see something decent. We're looking at here's that southern hemiswell, by the way. Yeah, that was supposed to come in on Monday, Tuesday. 1.5 feet at 15 seconds sort of thing. 1.4 feet at 14 seconds. And then, and some more swell. 1.2 feet at 15 to 16 seconds. So this is all the southern hemiswell with none of the North Pacific swell because, for the most part, it's all shadowed. Oahu, we were already seeing, 22nd period energy on the buoy. That swell should be hitting as we get into Monday with surf heights in the 6 to 7 to almost 8 foot range. That's slowly fading off, but we know that there will be more coming behind it. Let's see what we got here. 3 feet, 17 seconds. Early Monday, building to about 5 feet at 15 to 16 seconds, and then just holding steady the whole way through the week. 4.5 feet at 14 seconds, 13 seconds. That starts trailing off, but there'll be more energy right behind that. And for fun, our friends on the East Coast, Cape Hatteras Lighthouse, surf heights, 8 feet today, supposedly fading to 4 feet, coming back up again as low pressure continues circulating off the coast. Just this steady sort of rideable surf pattern. Winds, though, look at this, north 36 knots, 22 knots, 23 knots, finally starts settling down on Saturday and then starts coming up out of the southwest. Let's look at swell heights. For Monday, 6 feet at 10 seconds, 4 feet at 11 seconds, 7 feet at 9 to 10 seconds. I mean, this is actually a great pattern. 4 feet at 11 seconds. Surf all week long. Just got to find the right location, protect it from the wind, make the best of what you can get. All right, let's go take a look long term. Let's go look at the two major weather oscillations that affect the potential for surf and or snow. That is the MJO, the Madden-Julian Oscillation, and ENSO, El Nino Southern Oscillation. We'll start with the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. They rotate around the planet on the equator, west-east. The active phase on one side of the planet, inactive phase on the other, rotating around west to east. It takes, so the active phase or inactive phase take about 4 to 5 weeks to make it from the West Pacific to the East Pacific. So you can get these patterns where the surf will pump for like a month and then it'll go quiet for a month. That's typically being driven by the active phase of the MJO. The active phase of the MJO is like a low pressure system. It takes warm, moist air down at the ocean's surface, lifts it aloft. That warm, moist air eventually condenses in the upper levels of the atmosphere, making more clouds than normal, but also feeds energy into the jet stream, making the jet stream stronger, make it more capable of digging out troughs. And if you have troughs and energy, the jet stream is consolidated, and that makes low pressure pressure systems that make storms over the open waters of the North Pacific, which can create surf. And then as those low pressure systems, and especially as the active phase of the MJO moves west to east, under, again, it's on the equator, under or south of California, that can drag the jet stream south over California, creating precipitation. So the inactive phase does basically exact opposite. It's a high pressure system. It cuts off its downward falling air, cuts off the flow of moisture to the jet stream. Wherever the active phase or the inactive phase of the jet stream is, the jet stream gets weak, fragmented. It's not very supportive of digging out troughs, and therefore not good for producing surf. So, the active and inactive phase dramatically affect trade winds. That is, the active phase of the MJO, because it's a low pressure system, and trades are generated by high pressure circulating around. The low pressure cuts the legs out of the high pressure system and dampens trade winds, if not actively reversing them. Conversely, the inactive phase of the MJO makes trade winds stronger. It's a high pressure system. Trades are generated by high pressure. High plus high equals doubly strong high, if you will. So, but what the good news is, you can monitor that using this chart here, the TAO buoy array. It's a series of buoys strung across the equator. This is the East Pacific here. This is the West Pacific here. New Guinea there. Date line right there. There's your equator. The buoys have wind sensors on them, and you can monitor. It's 5-day average winds, but it gives you an idea of what the trades are doing. Okay, so you can see the trades, the length of the arrows, blowing pretty hard out of the east and the East Pacific, even harder yet over the Central Pacific and pretty hard over the West Pacific. But it's not the actual trades that matter, because the trades always blow. The question is, are they blowing harder or weaker than normal for this time of year? That's what anomalies are. Are they blowing harder? Well, we look here in the East Pacific, looking at the arrows, it's like, no, they're not going anywhere. This is pretty much normal. Same thing over the Central Pacific. In the West Pacific, I call it the Kelvin wave generation area, because this is, if you have El Nino, this is where the active phase of the MJO starts interacting with El Nino and really dampening trade winds, creating west anomalies, and this is where you can create Kelvin waves, warm water pushing off to the east. But anyway, for this evening's presentation, trades a little bit stronger than normal. So no clear sign of the active phase, no clear sign of the inactive phase. If anything, it's a little inactive here. Pretty much typical of what it's been. We talked about this last week in the video. MJO has been exceedingly weak, but we think maybe that's going to change. What is the forecast for trade winds over the next week? Or 2 weeks, actually. So this is 850 millibar zonal wind anomalies. The anomalies, are they stronger or weaker than normal? The blues, stronger than normal. The yellows, reds, weaker than normal. This is past performance. This is the forecast here. But this is for the whole planet, not just the Pacific Ocean. So to get ourselves oriented, 125 east is about as far in the West Pacific as you can go. Date line right there. The main area we're worried about is the Kelvin wave generation area. If west anomalies are over there or approaching there, they will feed the jet stream, and as the jet stream moves east over westerly anomalies, that will give it energy and momentum. So, as we can see here for the next couple of days, kind of just this week, mixture of neutral anomalies or slightly stronger than normal. But you see the trades really start picking up on October 19th and hold on the date lane the whole way through the end of the model run, so right up to almost Halloween. But you see westerly anomalies, not in the Pacific Ocean, over the maritime continent, but building. We haven't seen anything like this or like this for quite a while. This sort of smells like somewhere in mid-October, maybe the MJO might finally wake up. Outgoing long wave radiation forecast here at OLR. All that means is fancy words for cloud cover. Do you have more clouds or less clouds than normal? Active phase of the MJO, because it's taking warm moist air, lifting aloft, creates more clouds. Inactive phase of the MJO, because it's high pressure and falling air, it's dry air, less clouds than normal. The yellow, less clouds than normal. The blues, more clouds than normal. That is let the clouds soak up outgoing long wave radiation for the Earth, so you get negative anomalies. All right, so South America, Central America, New Guinea there. EQ is the equator. 180, that's the date line. Each panel is for 5 days, so this is currently showing inactive phase, the MJO over the Kelvin wave generation area. Basically the same thing, 5 days from now, 10 days from now, and then going neutral 15 days from now, 2 weeks, while the active phase of the MJO starts building in the Indian Ocean, approaching the maritime continent. This is from the statistic model. The dynamic model basically saying the same thing, but saying the inactive phase for the next 2 weeks holding solid while the active phase builds in the west. So the two models pretty much in sync. And then phase diagrams for the same two models, statistic model, dynamic model here. This is just showing you where the active phase is and how strong it's going to be, what its track's going to be, just the active phase. How do you read the chart? Well, the active phase moves from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot, which is right here, is where the active phase is today, so over Africa. And if the dot is anywhere near the circle, it's considered to be extremely weak. So an extremely weak active phase over Africa. The forecast, 1, 2, 3 different lines here, all have it lined up somewhere in the East Indian Ocean and exceedingly weak 2 weeks from now, according to the statistic model. The dynamic model, though, shows the active phase getting stronger, and I'll call it modestly, not quite moderate. Moderate would be up out here, further away from the circle. So modestly active over the maritime, approaching the maritime continent 2 weeks from now. Next up, the CFS model. We were looking before at a statistic model and the GEFS, the GFS ensemble model. That only goes out 2 weeks. CFS model goes out, well, in this rendition of it, out a month, 1, 2, 3, 4 weeks. This is the same thing, 850 millibar zonal wind anomalies, so the wind's up at about 4,700 feet, but that's a good proxy for what's going on at the ocean's surface. The blues, easterly anomalies, the reds, westerly anomalies, so roughly the active phase, the inactive phase and the active phase. But we have the benefit of actual MJO, the black line indicated here. Dotted would be inactive, solid would be active, but you see these aren't even cohesive I've told you the active phase moves the whole way around the planet. These are just like little hints of it. Now, here we go. And when I say I think the MJO is waking up, because the models are all starting to coalesce around this idea of we're going to have a legitimate inactive phase to start things off. 2 contours, but you see it migrating from the maritime continent the whole way to a point not quite south of California, but at least making it a good long ways across the Pacific, with 2 contours for the next 2 weeks sort of thing, with relatively strong easterly anomalies. I say that, but you see the models are also predicting storms. My guess is inactive phase, that pattern will continue, but the inactive phase will just sort of shunt the storms more to the north. They won't fall deep south into the Pacific. It's way too early in the year anyway. But the other good hint here, look at this. Another or a legitimate active phase forecast behind that as we get into the week of Halloween, the first week in November, with westerly anomalies making it halfway across the Kelvin wave generation area. This is a tease of what I think is to come. Let's go look at one more model. And here's the CFS model going out 3 months, right? I tell you, don't believe a model going out more than 5 days, and then I'll show you a model that goes out 3 months and then get excited about it. So take it with a grain of salt. Past performance is down here. This rendition has the forecast up on top. There's current time. The date line running right up the middle. Far West Pacific starts about 125 east, so right here. So this kind of it's the CFS model again, suggesting the same thing. It shows sort of this mixed bag of easterly and westerly anomalies for, we'll say, the next 5 days to maybe a week. And then you get this clear, the blue easterly anomaly pattern setting up. This would probably be the inactive phase of the MJO. But then you go 1, 2 weeks out, maybe 2.5 weeks, something like that. And again, the models have been hinting at it for months now. It's never happened, but westerly anomalies theoretically building over the date line. And then as we get into November, basically filling almost the entirety of the Pacific. Now, certainly I'm not going to say the El Nino word, but it clearly looks like the death of La Nina in some degree, if you believe the model. Let's overlay the MJO here. Let's see where, okay, here we go. Notice relatively weak MJO regime indicated, but then we get a inactive phase here that makes it a good to a point into the Atlantic Ocean. 60 west is halfway across the Atlantic, okay, with 2 contours and easterly anomalies. But then as we get to November 5th, the active phase of the MJO makes it into the Pacific, and then not only makes it to the Pacific, makes it the whole way into the Atlantic and probably beyond that, dragging westerly anomalies with it, and those westerly anomalies persist, filling the bulk of the Pacific through the end of the model run, so almost the second week in January. Would I believe that? Why would I believe it? Well, let's see why the model is suggesting that. Overlay the low pass filter here, and this really tells the tale. This is the solid contour, low pressure bias. Think of it as El Nino. The dotted contour, high pressure bias. Think of it as La Nina. Right now, low pressure. Well, let's see. Oh, the far west Pacific starts 125 west. And as of even in August, the low pressure bias is filling half the Kelvin wave generation area, the high pressure bias filling the other half. That's why we've been saying the West Pacific is probably going to dominate this winter, because that's where low pressure is. But you also notice here, as we get into like Thanksgiving time frame, all of a sudden the low pressure bias starts making its move off to the east. And the high pressure bias, this is what's driving La Nina, completely dissipates as we get to the first week in January. The model has been vacillating somewhere, give it a week or two one way or the other, but sort of hinting at this whatever La Nina pattern we're in, which seems very weak as it is only going to get weaker as we get deeper into fall and early winter, as the MJO starts waking up and starts influencing the atmosphere. So all in all, if you believe a model out 3 months, things are definitely going to take a step in the right direction. So now let's go to the El Nino, La Nina portion of the discussion. We're going to start by looking at subsurface water temperatures. Where the balance of warm water is in the equatorial Pacific can kind of tell you whether you're in a La Nina pattern or an El Nino pattern. We're looking at data from the TAO buoy array, a series of buoys strung across the equator. These are the anchor lines on those buoys. The X's are the individual sensors strung down those anchor lines. That, with a model, fills in the gaps and tells you where the balance of warm and cold water is on the equatorial Pacific. Just eyeballing the chart, you can clearly see warmer water. This red line here is the 29-degree isotherm, is in the West Pacific, and the warm water is much shallower in the East Pacific. This is a classic kind of La Nina-ish kind of pattern. If you were in El Nino, a bunch of this warm water, or at least the isotherm lines here, the warm water depth would be a lot deeper in the East Pacific. All right, so the 29-degree centigrade isotherm today is at, what is that, about 73 east, which is about what it was last week. The 28-degree isotherm at 170, I actually think it was back at like 72 or 73. So it's actually made a little eastward headway. The 24-degree isotherm, well, 2-3 weeks ago was at 120. It's backtracked some to 130. So this is kind of a mixed bag, steady in the west, maybe losing some ground in the east. But it is the anomalies again, the difference from normal for this time of year. I thought we were making headway earlier this week because I saw this -3 disappear. It was down at -4 one point. It was just 2-degree anomalies, but now all of a sudden we have -3-degree anomalies centigrade below normal, right where they've been. So this still suggests La Nina. All our warm water pulled up in the west, cooler water in the east. What this really is trades are blowing stronger than normal over here. That takes the warm water that's normally here for this time of year, pushing it this way, creating negative anomalies in this area. And then there's another version of this chart here. It uses the same buoy data, but it also has satellite data overlaid in there too, and we'll look at that in a minute. But it's basically painting the same picture. That said, the warm anomalies have moved to about 140, maybe 145. For a month ago, they were at 160. That suggests maybe the trades are a little weaker, and they're still stronger than normal, but not as strong as they were, allowing some warm water to make its way off to the east. Here's your cool pool, still there. Temperature's still cooler than normal, being driven by stronger trades, at least in this portion of the Pacific. This is the satellite data, sea level anomaly in centimeters for October 5th. It updates about every 5 days. So Chile, Peru, Ecuador, this is the equator. This is the international date line. That is New Guinea right there, the Galapagos Islands right there. There is a little bit of sign of hope here in that there were 15 What the satellite does is it measures the height of the sphere of the ocean. That is, take out the waves, the wind waves, the tides, and is the absolute sphere of the ocean higher or lower than normal. Why does that matter? Well, if you have cold water at depth contracts, it displaces water, you end up with a divot on the ocean surface. Warm water at depth expands, you get a bump on the ocean surface. Here's your bump over in the West Pacific, 5 centimeters, maybe 10, not a huge bump. And here's your divot off of Ecuador, suggesting stronger than normal trade, suggesting the upwelling, suggesting, colder than normal water at depth, -10 centimeters. It was down at -15 2 weeks ago. So some hint of maybe a slackening of the trades. There's other data we're going to see here too that suggests also that things maybe are improving or not as bad as they were forecast in the East Equatorial Pacific. Upper ocean heat anomalies. So this paints the picture over time, so you can see it a little bit better than just relying on me telling you what was happening. You can see here, this is the West Pacific, East Pacific here. This is a whole year's worth of data. This is all on the equator, like 3 degrees north and south of the equator. Here is last winter's Modoki La Nina, cool water in the east, warm water in the west. This summer, we thought we were moving to ENSO neutral. You see warm waters made it across the Pacific. And then just like in July 15th or something, boom, the trades must have picked up. We started getting the upwelling and pattern again. Not looking as bad as it was last year. We'll see. I'm holding my breath. Notice warming waters building in the west as well. And here is you sort of can almost sense the MJO pushes here. This would be the active phase of the MJO with cold water. The inactive phase, I'm sorry. Here's your active phase, however weak it was, and you see the cold waters recede a little. Another inactive phase. Now we're in a maybe active-ish phase, kind of. Well, we saw the models. We saw the inactive phase is coming, so this probably won't last long. The subsurface temperatures give us a hint of kind of what is coming. The surface, not subsurface now, ocean surface temperatures tell us what is actually happening now. Okay, cold water, colder than normal ocean surface water prevents evaporation. Evaporation is lifting air. If you don't have lifting air, then you have falling air. Falling air is synonymous with high pressure. So what we have here is South America, Central America, Hawaii, New Guinea, the equator right there, date line right there. The blues, colder than normal temperatures. Here's your classic La Nina kind of pattern. Not super strong. In fact, temperatures in this area have actually warmed a little bit. This is, for the moment, the only real cooling that we see, just limited to right in this area. Like deeper cooling. Other than that, this is all this pretty minimal kind of cooling waters. Lots of warm water elsewhere, but it's only 5 degrees north or south of the equator in the Pacific that really is what's driving a good portion of the global weather circulation. So for now, La Nina pattern appears apparent, but not very strong, and if anything, maybe weakening a little bit. Let's keep digging. The 7-day temperature trend. Well, okay, we said it was warming in this area, but over the past 7 days, it looks like it's trying to start cooling. But you really see here, you got bits of warming here, a little bit of cooling here. I mean, it's almost like a mixed bag. Yes, there's probably right in here, this, 20-degree distance, which is 20 degrees. That's 1,200 nautical miles right in there. That's probably where the strongest of trades are, where everything else, not too impressive. Oh, you also see Priscilla and some other tropical systems. I think it was Narda, all went through this area. They created upwelling. So you can see a storm for a couple of days can, change water temperatures pretty quick. Alternate sea surface temperature anomaly chart just uses totally different technology to try to tease out the global warming signature. So this just says, okay, average temperatures of the oceans over the whole planet are, boom, and what's the deviation from whatever that number is. You see, it clearly paints a La Nina picture this way. Sea surface temperature trend. This is for the Nino 1.2 region. This is that area right there by the Galapagos and Ecuador, and a little bit beyond there, where I said temperatures had been warming. They were, but now you see them falling. Today's value, 912 thousandths of a degree below normal, so almost a degree below normal. This is not the official El Nino monitoring region, but you can see since, I'd say about August 22nd or so, we've been in some flavor of a La Nina-ish pattern in this area. Here's the official El Nino monitoring region, the Nino 3.4 area. The area on the equator, 5 degrees north and south of the equator, from point south of California out to about the dateline. Temperatures today, 891 thousandths of a degree below normal, so 3/4 of a degree below normal. Now, and you can see, though, we've been pretty much steady since the end of August. Maybe a slight downward trend. It doesn't seem like we're off to the races going to get at least any cooler than we currently are, at least based on this trend. But what is going on in the atmosphere? The ocean looks like La Nina. What's the atmosphere say? So we look at the Southern Oscillation Index. It's just a running tab of the daily pressure at Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin roughly over the Indian Ocean. If pressure is lower in Tahiti, the index goes negative. If pressure is higher in Darwin, if pressure is higher over Tahiti than Darwin, then the index goes positive. Today, 8.31. Positive index suggests at least the inactive phase of the MJO, if not La Nina. But let's see, that's 1 day. 1 day doesn't mean a whole lot. I'm just scanning down here for the month. All the values generally look to be positive, other than this run of semi-negative numbers back in mid to late September. All right, so let's go do an average, 30-day average. Today's value plus 3.76. That's like nothing, I mean, where were we a month ago? 4.33. Now, this is highly affected. Both these are by the MJO. Active phases driving it down, inactive phases driving it up. You can see here we were about 0. We're creeping up a little bit, and we know the inactive phase is coming, so this is probably going to go higher. But that said, until this is up at like plus 15 or down at minus 15, it's not really a big deal. The 90-day average, plus 4.10. Where were we a month ago? 3.51. Statistically speaking, that's like nothing. So dead neutral. Let's go look at this on the graph. Here's the 30-day running average of the Southern Oscillation Index. Here we are. This is as of the 10th of October, but you can see neutral. They consider it plus 7 to minus 7. That's like ENSO neutral. We've been as neutral as you can get since sometime in May. Very, very weak MJO. Yeah, the downward spikes are the active phase of the MJO, upward spikes the inactive phase. MJO basically has been asleep since spring and all summer. We think that's going to change here in the next week or two. Would I bet on it? Probably not, but will I be teased by it? Yes, I will, and I'll get a little bit excited by it. So here's the forecast from the CFS model for sea surface temperature anomalies in the Nino 3.4 region. And October data, actual data, just got posted like today or yesterday. And the model previously, before that posted, had been showing temperatures down somewhere around here. And now the actual posted, boom, it went up. And the model continues to show, yeah, we're going to fall, but just as quickly as we fall, like November is the bottom of La Nina, and after that we start heading up. I'm not even looking at this. I don't want to tease myself. I just refuse to go there. But looking in here, this suggests that the models were projecting, at least this model was projecting a kind of good build in La Nina in mid-October. And that did not happen. Officially speaking, this temperature value right now, that's actuals, is like minus 0.45 of a degree, is considered ENSO neutral, half a degree above to half a degree below. So even at the ocean surface temperature perspective, theoretically, we're neutral. This is the more aggressive version of the model. Here's the PDF corrected. It's showing the same thing. It shows us go to La Nina for the month from mid-October to mid-November. By mid-December, we are practically, once you're half a degree, at the half a degree mark, you're considered ENSO neutral. So this is effectively 1 month of La Nina, and then it's all over. This is not, well, it is from the CFS model. So this is probably picking up on what the CFS model is saying about westerly anomalies building and all that sort of thing. But either way, looking positive. Let's talk about that. So for right now, the models are looking reasonably positive for the time of year. Gale forecast, little one in the northwestern Gulf, a stronger one in the Gulf of Alaska, 5 or 6 days out, and a much stronger storm on the dateline. And more energy potentially behind that coming from the tropics. Hard to say. Again, it's a bit of a reach. This westerly anomaly pattern that is forecast by the models appears to actually be in reality happening in the West Pacific. Again, the focus of storm development in the far West Pacific, that pattern appears to be playing itself out right now. Multiple recurving tropical systems off Japan is certainly a good hint. Now, let's be clear. Once you get over the dateline, it's east anomalies and all that in the East Pacific. So the focus is West Pacific. The model says, though, 2.5 weeks from now, active phase of the MJO coming. Well, one, the MJO waking up. First inactive, and that's happening like in the next day or two, followed by an equally strong active phase of the MJO, dragging west anomalies across the bulk of the Pacific, and the high-pressure bias fading as we get into December over the East Pacific, and temperatures not falling as fast as were projected for La Nina, and the length of this La Nina, at least per the latest model run, looking much shorter than was previously suggested. In fact, the consensus models all the other models were sort of saying, now this is going to be a short-lived La Nina, and the CFS was kind of the minority report, predicting somewhat a gloom and doom type scenario. That looks to all be for naught, and that maybe a weak La Nina. I mean, officially, it wouldn't even qualify as a La Nina. So we'll see where we go here. And even better yet, backdoor cold fronts in play. I mean, that does sort of hint at, well, there is La Nina. It's almost like La Nina is in the East Pacific and a very weak El Nino is in the West Pacific, and that pattern is going to get more entrenched as we move deeper into winter. that would be a very good thing. Plus, the other good news here, snow for the Sierra, rain for California, even rain down into Southern California. We'll take every drop we can get, no matter how we get it, no matter how oddball the weather situation that produces it. This year, based on what's been forecast, every drop of rain counts. We'll take it. So, for now, cautiously optimistic outlook. Short term, yeah, there's gales coming. Longer term, maybe a better pattern than we had hoped for. Too early to know. I'm not going to get over my head over my skis yet, but we'll see. I think there is reason to be cautiously optimistic. With that, we are done for this week. If you enjoyed the video, please give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Comments, questions. If you don't believe any of this, you think I'm just, making up stuff here, go for it. Yeah, give me your thoughts. I would love to hear what you have to say. It's always good when we can share our opinions in a healthy manner. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below. Again, thanks everyone for the large amount of contributions this past week. I was really floored, so thank you. And that is it for this week. We will do it again next week, same time, same channel. Thanks so much for watching.